Our modern complex industrial world has found them insufficient and has turned elsewhere to fulfill its needs. Turned to a fourth kingdom, a kingdom of scientific research, a new domain of man's own creation, a world of primary substances which never existed before. The aristocrats of this new realm are the phenolic plastics, of which bakelite resinoids are the first family. Out of the discoveries and patents of Dr. L.H. Baekeland has grown a world-circling empire of plastics. And here is its capital, Bound Brook, New Jersey. Every building and room of this modern 125-acre plant was designed for but one purpose, the manufacture of bakelite materials. Its production equipment is the perfected development of a quarter-century's experience in making plastics. From many raw materials are now manufactured an infinite variety of primary resinoids covering a wide range of special characteristics and properties. These, alone or in combination with numerous fillers and solvents, make up the more than 2,000 different bakelite materials. They are supplied to the trade, ready for use, in manifold forms suited to fabrication and quantity production. Molding materials, for example, are prepared as powders, molding flakes, board stock, and blanks. But regardless of form or application, all bakelite materials, by virtue of their primary ingredient, the resinoid, possess in common a unique combination of superior properties. Exceptional in their tensile and impact strength, hardness, durability, and electrical characteristics, they have in addition high resistance to heat, water, and chemicals. Any of these qualities, furthermore, may be augmented by varying the type and amount of the modifying agent. The molding powder pouring into these telephone shell molds is prepared by combining resinoid with a cellulose filler. Fillers such as this and cotton fabric, asbestos and minerals are incorporated in molding materials for their added value. Better molding qualities, greater toughness and strength, and in the case of mineral fillers, an increased degree of water and heat resistance. But the resinoid is the important ingredient. And it's this combination of characteristics, rather than any one single property, which inspired the use of molding materials in so many different products. Bakelite materials entered the automotive field in molded distributor heads when Charles F. Kettering developed his Delco ignition and starting system. In these new plastics, Mr. Kettering found the dielectric strength, the resistance to heat, acids, oil, and moisture, in fact, the very insulating material which he needed. Now there are over 200 resinoid parts in the modern car. Long before listeners had heard the term radio, molding materials were aiding the makers of radio's parent, wireless telegraphy. Today, they guard 1,001 vital spots in the great broadcasting stations and home receiving sets. In the electrical industry, the molding of instrument cases is typical of simplified production. Formerly involving 15 machining and finishing operations, they now are made with resinoids in a single closing of the press. Big or little, resinoid molding materials are equally adaptable, as witness these tiny insulator bushings and these two examples among many home electrical devices. Development of scores of materials for special uses has prompted the spread of molded applications into many diverse and new fields. Here, for instance, are products fabricated from a more heat-resistant material of the mineral-filled type. Another new variety, impact materials, has several times the shock resistance of ordinary molded plastics. This product consists of phenolic resinoid processed with specially selected fibrous fillers. Holding the spotlight in modern merchandising are packages and closures produced from molding materials. The unmistakable feel of quality, the sales appeal and utility of these colored molded products have earned their approval by retailers and public alike. Then, too, the inert, chemical-resistant properties of the materials make possible sanitary leak-proof jar, tube, and bottle tops. These resist alcohol and are non-corrodable. Novelties likewise have joined the army of products whose appearance is enhanced through the use of these brilliant surfaced materials. Transparent materials are produced from pure resinoid without the use of fillers. They are cast in lead molds and converted into consumer products by machining. Rivaling precious jewels in color and depth, they are among the most beautiful of resinoid products. For the manufacturer, artist, designer, and amateur craftsman, they have opened up a new field of wide possibilities. And for the public, new means of decoration and service.
This jet necklace, madam, is Bakelite resinoid. We consider it equal, if not better than the natural mineral.
It's beautiful, and how light. And so smooth and warm to the touch. But will it keep its fine appearance?
Yes, permanently. As a matter of fact, Bakelite jewelry has many advantages over glass, porcelain, and natural stones. To start with, it's flawless. Then, too, it is strong and hard without being fragile.
The material in this holder is so strong that a 7-passenger car can be hung on a 1-inch rod of it. An engineer told me that.
Well, then it can't be amber. That's quite brittle.
No, sir, it's called Bakelite resinoid. Notice the smooth surface on this pipe stem. The material is dense, non-absorbent, and has an enduring finish. That's why it's not affected by mouth or tobacco acid.
Among their many strictly utilitarian uses, Bakelite transparent materials, by reason of their chemical-resistant properties, supply graduates, bottles, and other laboratory apparatus which must withstand the destructive action of hydrofluoric acid, and thereby they meet a century-old demand of chemists. Laminated materials are products of the chemical merger of phenolic resinoids with layers of paper or fabric. Under controlled and recorded conditions, great rolls of laminating fabric are uniformly coated with resinoid in varnish form. But in any of its forms, sheets, tubes, or rods, laminated makes available to industry a material with high resistance to moisture, uniform wear, resistance to temperature and chemicals. Outstanding also are its ease of fabrication and remarkable insulation qualities, its freedom from fracture and structural variation, its high tensile and compressive strengths. Its applications are legion. Suited to mass production, all manner of articles are punched from it. In a host of parts on practically every make of radio set, Bakelite laminated has become the standard insulating material. Equally wide is its service in 100 critical places in central stations and throughout the electric power industry. It may be had in a range of colored effects from lustrous jet black to robin's egg blue, combined if desired with tinted metal inlays and photo murals. It is the newest and most versatile medium of the modern designer and architect. Bakelite lacquers are made by dissolving primary resinoid in suitable solvents. Light amber in color, they are intended primarily as protective coating. To highly finished articles, they are applied by machine dipping or by spraying with standard airbrush equipment. The thin film of resinoid is then oven baked into a brilliant and wear-proof coating. By reason of its high mechanical bonding strength, dielectric value, and resistance to oil, water, dirt, and gasoline, Bakelite varnish is widely used as an insulating bond and protective coating for coils, armatures, and windings. To automotive brake linings, it imparts long life and resistance to friction heat. It even protects museum fossils. Resinoid cement contains a solid reinforcing body in addition to the resinoid and solvents. One type, lamp basing cement, has long been used to seal electric lamps and radio tubes in their bases. The gluing together of sheets of wood or veneers, now called plywood, dates back 35 centuries to the Egyptian pharaohs. But until the introduction of resinoid bonds for the plywood industry, delamination and stains were a constant source of trouble in wet gluing. These resinoid adhesives knit the wood fibers securely together and form a synthetic wood, more uniformly durable and stronger than the original lumber. And heat, humidity, water, vermin, and fungi, none of these enemies of ordinary wet glued veneers can impair the lasting qualities of resinoid bonded plywoods. Furniture and product finishes demand gloss, luster retention, and durability. Aircraft finishes need resistance to sun and sleet, fumes, and dirt. Yacht and marine craft finishes must withstand sun, rain, and salt spray. These are but few of the specifications of Bakelite resin paints and varnishes. Born in a chemist's test tube into the fourth kingdom of primary substances, resinoid plastics grew up and were made useful in these extensive research laboratories of the Bakelite Corporation. And here, too, they are multiplied and adapted to the future needs of every industry on Earth. Their limitless applications can be measured only by the sign for infinity, and that's the symbolic trademark of Bakelite products.